This is the third kind of factoring I showed you. What was the first? GCF. What should you always try every time? GCF. Second, trinomial factoring, which looks like this. 1 was GCF. 2 was trinomial factoring. X squared plus bx, some number there, plus c, some number there. We talked about that one. You got to multiply to c and add to b, right? That's what you've already known. Now we're on to the third one, okay? Now this is going to be very, very simple, and you actually have already done it, okay? Without me telling you, you've already done it. If you see this, what are you going to do? You're going to expand it, yeah? So let's expand that together. X times x is x squared. X times negative 4 is negative 4x. New term, new line. Plus 4x minus 16. And what do you get when you straighten it all out? X squared 0 plus 0x minus 16. Would we ever write that in math class? No. Of course not, because we don't write 0. So what do we actually write? X squared minus 16. Have a look at that. Have a look at the title of this kind of factoring and put that together in your brain. Difference of squares. What math is difference? That's subtraction. Squares must mean we have a difference can only happen between two things, right? So squares must mean it's two perfect squares. Do I have that here? Yes, I do. Why? Because x squared is a perfect square and 16 is a perfect square, right? Now you guys are smart kids. This is the expanded form, yes? Which means this must be the factors, yes? Now you already know there's going to be a shortcut, right? Because there's been a shortcut to every factoring we've done. What is the shortcut that compares 16 and my factors? What is the relationship between 4, 4, and 16? It's a square root, right? What is the relationship between x, x, and x squared? It's a square root. If it happens once in math, when does it happen? All the time. So if I have a difference of squares, which would be this, anything squared minus any other thing squared, when I factor it, what do I get? Well, I started with x squared. When I factor it, I got x and x, which is the square root, isn't it? So it factors out to the square root of a plus the square root of b, whatever it is, and then the square root of a minus the square root of b. Does everyone see that? And I remind you, you have already done this. What? We never did that, Mr. Myers. Yes, you did. If you go back to page 13, what do you see right here? How should that really be written? X to the 6th minus 144. Right? Hey, Emma. Right? What should this really be? X squared minus 64. Perfect square minus a square. Perfect square minus a square. Everybody with me? You've already done this. You've done it the long way, because here, of course, you recognize you had to multiply to 64 and multiply to negative 64 and add to 0. That's how you did that question, right? So when we actually write it out properly as square root, now that you've already known how to do it properly, I give you the shortcut. Is everybody with me? Now I'm giving you one of the hardest ones first. Okay? There's a reason for that. If you understand, because this is the tricky one. If you get this one, everything else is gravy. All right? Now, first of all, what are your hints here that it might be factorable? You know that 1 is a perfect square, yes? 1 times 1. And you've got subtraction, so you're halfway there. Is x to the 16th the perfect square?
Yes.
Yes, it is, because it's 8 times 8, right? It is x to the 8th times x to the 8th.
4.
No, guys. Exponent laws. Grade 9. What do you do with those exponents? Add it. You're not square root the exponent. Everybody with me? It's grade 9 exponent laws, which I'm going to review this year in a little bit. When I add 4 new exponent laws to it for you. Everybody remembers this, yes? So, remember, I'm doing the hardest one first. When it was x squared, it factors to x times x, yes? What's it going to factor to if it's x to the 4th? Squared and squared. What if it's x to the 6th? 3 and 3. What's the pattern? Squared factors to 1 and 1. 4 factors to 2 and 2. 6 factors to 3 and 3. What's x to the 8th factor to? 4 and 4. So what's the pattern? Divide it by 2. Can I do this? Is x cubed a perfect square? No, because it's called x cubed, isn't it? That won't work. Will x to the 5th?
No.
Why? Has to be an even number, doesn't it? All stuff that you already know, right? So, we now have decided that this is a perfect square minus a perfect square, yes? So all I do is I take the square root of the first one. What's the square root of x to the 16th? We already know it's x to the 8th, right? And what's the square root of 1? 1. X to the 8th plus 1. And then we write it again. X to the 8th minus 1. Everybody cool? Now, a great many of you are going to stop there. Is that okay? I told you I'm giving you the hardest one first. Did that seem difficult?
No.
No, so there must be more to it, yeah?
Yeah.
That's adding. Have I taught you how to... Is there a way to do a sum of squares? What was this section called? Difference of squares. Is there a way to do a sum, do you think? Let's check. Don't write this down. X squared plus 16. Now, when it was a difference, we knew it was x plus 4, x minus 4, yes? Right? But it's not that anymore. It's a plus 16. So isn't that officially x squared plus 0x plus 16? Is everybody still with me there? Now, if we were going to factor this, I would need numbers that multiply to what? 16 and add to what?
0.
What are they?
8.
Negative 4 and positive 4 will not multiply to positive 16.
Negative 4.
Negative 4 and negative 4 will not add to 0. Is everybody with me? You can't do a sum. Does everybody see why? If I do x plus 4 and x plus 4, there's my positive 16, yes? But when I FOIL it, don't I need a 4x and a 4x? That'll get me 8x's, won't it? So that's out. Okay, Mr. Myers, wise ass, it must be x minus 4 and x minus 4. 4 times 4 is positive 16. I got you. Except, why doesn't that work? Negative 4x, negative 4x. I need a negative 8x. Everybody cool? Now, normally I would take half a period and we would discuss why this works. But we're behind, right? So I'm cutting to the chase. So I can't do anything with this, can I? Because it's a sum of squares. Look at the next term. Is x to the 8th the perfect square?
No.
Why, Christina? because it's got an even exponent. Is 1 a perfect square?
Yeah.
Is it a subtraction in the middle? So we got to do it again, don't we? So what do I get? X to the what? 4th plus 1. Can I do anything more with that?
No.
Why?
It's an addition.
Because it's a sum of squares. And then x to the 4th what? Minus 1. Am I done?
No.
No. Why?
Even with a minus.
Because I have another minus sign. X squared plus 1. X squared minus 1. Am I done?
No.
No. Why?
Because 2 is an even number.
Because 2 is an even number. X squared plus 1. X plus 1. X minus 1. Am I done now? Yes, because I got no more squares that are differences. Is everybody okay with that? Please notice that all we did was the one thing that is new to you. Right up here. We just kept going until it was done. Kind of like if I gave you this. 14 over 28. If I ask you to simplify that, sure, it's 7 over 14. Is that simpler? Yes, but is it done?
No.
No, because it's of course 1/2. Everybody with me? You keep going till you're done. Now, look at the next one. It looks different. But is it?
No.
No. Those are both even, right? So all I do is I take the square root of that one. What is it?
XY.
XY. Plus the square root of that one. What is it?
15.
15. And then I do it again. XY minus 15. Cool? Everyone's cool? We're starting with stuff we can do in our head that makes perfect sense. Is everyone okay with that?
Mm-hmm.
Okay, let's go to the next one. What's my first one? Z what? 4 plus 12. Z4 minus 12. Some of you are going to tell me I can keep going. Can I?
Yes.
Why?
This 4 is even.
It's minus. Is it a difference of squares? 12 is square? No, so I'm done. Cool? This is the mistakes you guys make. You start seeing stuff and trying to fit it into the pattern. That's not a square, so it can't fit into the pattern. Is everybody cool? All right, now look at 4. 4 looks slightly different. Is it? No. Is x to the 6th a perfect square? Is 4 a perfect square? So can I get a square root of it? What's the square root of 4? 2x cubed plus 5y. And then 2x cubed minus 5y. Are we okay there?
Yes.
All right. Now, obviously, I've only given you 3 examples. This gets more complicated, doesn't it? But do you think it actually gets more complicated? No. It's the same thing. Everybody ready? Okay, we're going to start with a real easy one. 16, this is number 5. 16 minus x squared. These are bars that looks different. Is it?
No.
Why?
You just reverse it.
Still a square minus a square, isn't it?
Yeah.
So I take the square root of the first one. What is it?
4.
4 plus square root of the second one. What is it?
X.
X. Square root of the first one. What is it?
4.
4. Square root of the second one.
Minus X.
Minus. Any problems with that?
No.
Of course not. Everybody good?
Yes.
Okay. 1/9 x squared minus 25. Is that okay? Why?
X squared is it's a square root, like it's a square, and then 25 is a square.
And is 1/9 a square? 1/9 is a square. What is it?
It's 1/3.
1/3, right? What's 1/3 times 1/3?
1/9.
1/9. Everybody cool? So I take the square root of the first one. What is it?
1/3.
1/3 x plus,
5.
and then
1/3.
1/3 x
Minus 5.
minus 5. Everybody's still cool.
Yeah.
Yeah?
Yeah.
You're still cool? Number 7 is this. 16x squared minus 81y squared. Cool?
Yeah.
Why?
It's different squares.
Okay, so what do I do?
Square root them.
Square root the first one, which is what?
4x.
4x plus square root the second one,
9y.
and then do it again with the minus between them. Everybody's still cool. I'm going to slow down a little bit here because it's about to get a little crazy. Is everyone okay with that?
Mm-hmm.
Yeah? Okay. Number 8. 24x squared minus 36y squared. Does it look like you can do it?
Yeah.
It does. What makes you think you can do it?
Square.
Squared's minus, yeah?
Yeah.
But 24 is not a perfect square.
No.
But 36 is.
Yeah.
So what is the first thing I told you to try? Can I GCF that?
Yeah.
What is the GCF? 12, right? 12 comes out, leaving me with 2x squared minus 18y squared. Does that still look good? But you can't do it anymore, can you?
No.
Why?
Can't do each.
Because there's no way to make perfect squares. Is everybody cool with that one?
Yeah.
I put those in because a bunch of you are going to try and do what there? You're going to try and make this fit with your shortcut, aren't you?
Mm-hmm.
And you can't. It's as important to know when you're done as it is to know how to do it. Everybody with me? Everybody good? Now, can we make this so it does work? Is that possible? Because number 9 is going to be a extension of this. What if I had this? 32x squared minus 72y squared. Does it work as you look at it? When you look at it, it can't work because 32 and 72 aren't squares. But you should say to yourself, wait a minute, I gotta check this out. I better GCF them. What's the GCF? Somebody said it over here. I heard somebody whisper it. It's 8, right? So I'm going to bring out an 8, and that's going to leave me 4x squared minus 9y squared. Now will it work?
Yeah.
So I've got an 8. What's the square root of 4? 2x. Square root of 9? 3y. And then we just write it again. Is everyone okay with that one?
Was there like the newer care card? Was there one in a pair of earbuds seen in the bathroom? Because your class was in there at the time when I was in my shirts on.
Oh, I didn't lose a care card.
No, I lost.
Oh,
my
you
care
lost
card.
it. You guys were in changing, I assume, in the boys' bathroom. Anybody see a pair of earbuds and one of the new care cards. It'll have his picture on it, so it's easy to decide. It does have your picture, doesn't it?
No.
Oh, the grown-up ones have your picture. Doesn't look good, man. Is everyone okay with 9? Is everyone okay with 9?
Yes. Does it matter what order, like? The plus and
No.
minus
No. Doesn't matter at all. Okay. This shouldn't be here. You guys, I'm going to write down 2 more things that make this tricky. Okay?
2 more.
2 more. What if I gave you this? This is number 10. X minus 2 squared minus 9. What would you do with that?
Expand.
The immediate reaction is to expand it, yes? Don't expand it yet. Nobody expand. Your immediate reaction is to expand that, yes? Okay, can I show you something that will help you in the long run? What if I wrote this? A squared minus 9. What would you do? What would the answer be?
A minus 3.
A minus 3 and A plus 3, correct? What if I then told you that A equals X minus 2? What would you then put here for A?
X minus 2.
X minus 2 minus 3. What would you put here for A?
X minus 2 plus 3.
X minus 2 plus 3. What is X minus 2 minus 3? X minus 5. What is X minus 2 plus 3?
X plus 1.
X plus 1. Does everybody see that little trick?
Yeah.
Do you? Who's the boss of the question?
Yeah.
You are. You know how to do this, so just change it. Everybody good? Now, normally I would take a few days with this, well, a few minutes with this as well, and we would actually expand this out like Sam and all of you wanted to do to prove this was right. Do you all believe me?
Yes.
Because, of course, x minus 2 is x squared minus 4x plus 4, yes? Right? That's what that is squared, yeah? And then minus 9, correct? Everybody agree? And then that would be x squared minus 4x minus 5, yeah? And then we would factor that to be x minus 5 and x plus 1. Same thing if you expand. But I find this to be better. And there's a reason. Does math get more complicated? Yes. If you can do stuff that brings the math back to what you know automatically, does that make your lives easier? I think it does. And I'm going to show you why. You don't have to write down this last one because this one's crazy hard. But you may want to think about it. Look over here. I'm going to come over here into this mess over here. And I'm going to write it in blue. Just look at it and think about it for a sec. X minus 3 squared minus x plus 7 squared. Does that look like something that you could factor? Why? What about this makes it look factorable? You see a squared minus a squared, yes? Right? But that's a big ugly mess, isn't it? Until you do this. A, B. So that becomes A plus B, because that's A squared, right? And A minus B, right? What's A?
X minus 3.
X minus 3. Plus, what's B?
X plus 7.
X plus 7. What's A?
X minus 3.
Minus, what's B?
X plus 7.
X plus 7. Yep. What's x plus x?
X squared.
No. Plus 2x. What's negative 3 plus 7?
4.
4. What's x minus x?
Nothing.
Nothing. What's negative 3 minus 7? Negative 10. And now I just factored the hardest thing that you will ever see to factor, I think, in all of high school. Will you see many of these? No. But you follow the same rules. Is everybody good? Yeah? All right, so now, before we go on, remember how I said we're going to go back to number 4 up here and have a look at it? What do I need to do with number 4 to finish it? What's the square root of 9x squared?
3x.
3x. What's the square root of 16? Plus 4, and then I write it again. 3x minus 4. Is everybody cool?
Yeah.
Okay, now listen, please. We went down to here's what we just did. Notice how I skipped this? I did that because I'm moving that down to here. I find difference of squares easier than this, so I wanted to build up to this. I also told you to have a look at 166. Did anybody look at 166 and want any of that discussed? Everyone's okay? All right. So same deal here. We're a little bit behind. So have a look at it. Make sure you're okay. But actually do page 15. Because you guys are one ahead of me, yes? I ask this every block. Do 15 and do 17. And stop there. Okay? Now, guys, I'm going to assume, please listen up, I don't want to do a quiz on multiplying. We can all do FOIL, yes? Right? Even if I stretch it out, like even if I give you y squared plus 3y minus 6 and give you another one of them, you can even do that. If I do like one of those with the next few warm-ups, can we call that our quiz for that? Like everyone will be good enough with it if we practice it every day for a little while? Yeah? Okay. Because you're going to need to be able to do that really well next year. Actually, even a little bit this year. All right, so everybody knows what they need? Okay, now if I'm not mistaken, class goes till 1:20 today, yeah? 1:18, so you got 12 minutes to do like 20 questions. And most of them are add to 5, multiply to 7, right? Everybody good? Okay. We're going to do a quiz on factoring after next lesson is Monday. Expect a quiz on Tuesday, but I can't remember if that quiz is going to have what we do Monday on it. Do you understand what I'm saying? Because I wrote the quiz in summer. And I would check it, but it's going to be on the screen right behind me. And then you would see it. And that would be stupid of me, not you. It would be very smart of you, but stupid of me.
You should check the quiz then.
I could check the quiz, and I will right now as soon as I have done saying, expect a quiz on Tuesday. What is on it right now, I am not 100% sure, but I will be in a couple of seconds. Yes. Okay. Yes.
Okay, this one, there's nothing, this doesn't work. Oh, The first multiple that comes to your head, what is it?
1 and 40, 2 and 20, 5 and 4.
5 and 4.
No, 5 times 6 and 20. I had that to get back.
5 and 8. I wasn't sure if we were supposed to do that or not, and I had nothing to do with the cumulative test, so I did that. So, you know.
This is as a new year, but my review for the like a long time ago.
I don't know. Am I? It's in a stack here somewhere. Since I have till the end of January to do my marks. Oh, that's gotta come home.
No.
Can you which? If you need to.
X squared or X squared?
You're adding. So it's x plus x, so it's 2x squared. And you're not multiplying. Yes, because you're not multiplying. Yes. Okay, guys, like I'm hearing people talking.